Good morning and thank you all for coming to the 2016 AGM of Lithium Australia. Lithium Australia, as you're well aware, has concentrated over the last 12 months on developing advanced technologies to create a sustainable lithium future. Now, the premise of our business plan is to produce a processing system that has a low energy footprint, high byproduct credits and minimal exposure to mining cost. We can do that by capitalising on opportunities that already exist, and I'll tell you a little bit further down the track how all of that comes about. So primarily we're about lithium, but there are a couple of other things happening in Lithium Australia, and I should bring you up to date with what's going on and what you'll see in the near future. We recently acquired 100% of the Greenbushes project in Western Australia. That's adjacent to the world's largest lithium mine, and plan to use advanced exploration techniques that we've been developing in conjunction with SciAps out of the United States on that project. We currently have an interest in Metals Tech, which is about to float on the ASX, and priority entitlements have opened for Lithium Australia shareholders. Very soon we will award a contract for an engineering study utilising the Sileach process, which will give us an estimate of capital costs and operating costs, and we plan to undertake further pilot testing on spodumene at ANSTO in December 2016. But that's not all. In January of next year or thereabouts, we plan to start drilling at Sonora County in Mexico on the Electra project with Alex Resources. That's a very exciting lithium clay deposit, and we also have a proposed float early next year of our graphite assets as Graphite Australia. So lithium, what's it all about? Well, to a large extent it's about portable power, and today we're entering what I see as being the third phase of the industrial revolution and management of power. The first phase, of course, occurred when Stephenson's rocket rolled across the cobbles in London, steam-powered portable power. Following that, we had the internal combustion engine, and today it's all about batteries. It's lithium batteries, it's portable power, it's the capability of putting portable power in the palm of your hand if you need to, but this power can go just about everywhere. It creates the possibility of having renewable power 24 hours a day, and also the potential to make the common man a power trader. Lithium is the 33rd most common element on the periodic table, so it's quite abundant. It occurs in a wide range of rocks, but primarily in pegmatites, clays and brines. The interesting thing about that is it occurs in a lot of mineral systems that are mined for other commodities, and as a consequence today we believe that we see more material containing lithium going to waste than ever enters the lithium supply chain. That creates a great opportunity, an opportunity that we're certainly focused on. And the other thing is, it's interesting to note that out of the total lithium consumption of about 180 to 200,000 tonnes per annum lithium carbonate, only 100 tonnes or thereabouts gets recycled annually. So there's a great opportunity to recycle lithium and create a more sustainable future. Okay, the drivers to change in the lithium industry. Well, Lithium Australia holds the key to many of these changes. We've got 100% ownership of the Sileach process and the Lena process. They're both low energy processes, low exposure to mining cost as a consequence of being able to apply those to lower grade ores, off-spec concentrates and waste products, and in doing so generating a very high byproduct credit. The Australian government has taken notice of what we're doing, and we've had 2 federal government grants and 1 state grant, which has enabled us to create intellectual property agreements with ANSTO, the Australian Nuclear Science and Technology Organisation, which is operating a pilot plant for us in Sydney, and to engage Murdoch University in the deportment of waste material and the value-added byproducts. Feedstock to lithium carbonate production or lithium hydroxide, all lithium chemicals in fact, comes from two major sources. There are the brines that are dominated by the South Americans and the hard rock deposits dominated by Australia. You can see here the brine deposits, very large footprint and a residence time of about 2 years from the time of pumping brine into the evaporation ponds to the production of lithium chemicals. Those operations tend to be capital intensive but low operating cost. On the other hand we have the hard rock producers, primarily Greenbushes in Western Australia, that produces about 40% of the world's lithium. And the production of lithium chemicals from hard rock deposits tends to be a much lower capital intensity but higher operating cost. So globally we see the distribution of lithium within these two deposits split about 50-50. I like to draw a parallel with current lithium production and the technology used with the technologies that were previously used for the production of base metals. And if we go back about 100 years to the Broken Hill ore deposit, probably one of the most valuable pieces of ground on the planet. At that time, about 3/4 of the material coming out that contained base metals went to waste dumps. The reason behind that, there was no ability to separate zinc from lead. It took an enterprising brewer, a metallurgist and a mine manager to come up with a solution, and what is hailed as being probably Australia's greatest ever invention, and that was froth flotation. The advent of froth flotation enabled the waste dumps to be reprocessed, splitting the lead from the zinc and turning what was once waste into a very valuable commodity. We see a strong parallel in the lithium industry with a large amount of material going to waste. Some of this from mining operations that aren't lithium operations, they're other industrial minerals. Some from lithium operations being lithium minerals that can't be processed as a consequence of there being no available technology that can do it commercially, and other materials being low-grade concentrates that don't meet the cut for commercial product. The Sileach process has the ability to take any or all of these materials and potentially commercialise those, extracting lithium from the low-grade products and the off-spec materials with a high byproduct credit. And of course, in many cases, this material has already been mined by others, and so it comes with a minimum susceptibility to mining cost, and in fact, in many cases, no mining cost at all. So, what is the Sileach process? We started off by looking at a range of minerals. We found that under fairly normal laboratory conditions, these leached in different manners, and primarily we were looking at sulfuric acid systems. We started to wonder whether it wouldn't be possible to elevate the leach curves of all of these to the same level, and there must have been some fundamental reason why the leach curves were different. We found that by leaching in halogens, halogens are a group of elements on the periodic table. If we leached in halogens, we could in fact elevate all of those leach curves to the same level and effectively extract the lithium from most lithium minerals, or for that matter, solubilise, dissolve if you like, minerals in the silicate family all at the same rate. So the way we get the energy footprint down on this particular process is by generating sulfuric acid in a sulphur burning acid plant. That generates an enormous amount of waste heat. That waste heat goes into power cogeneration and the heating of solutions as required for the metallurgical circuit. The sulfuric acid is added to other reagents to create a halogen-rich solution, and that halogen-rich solution attacks the ore minerals, liberating the lithium, and for that matter, all other metals that are contained within the silicate lattice. Those metals include aluminium, silicon, a whole range of alkali metals if you're dealing with lithium micas, and other metals in accordance with whatever else you put into the system. Solubilising those metals makes them all available as byproduct credits, so they can actually be extracted as commercial products. Okay, the steps involved in commercialising the process are fairly standard. There's laboratory testing, there's been an enormous amount of that done, pilot testing which is being undertaken at ANSTO, and then from there we'll do the engineering design studies which will give us the ability to determine the capital and operating costs and subsequently commit to the construction of a large-scale pilot plant. Now those steps are critically important, in particular if you have a look at the commercial arrangements we have with other parties, and in particular Pilbara Minerals. If we establish a large-scale pilot plant and operate that successfully and demonstrate the commercial viability of the process, we will subsequently enter into a 50-50 joint venture with Pilbara Minerals to process spodumene from the Pilgangoora deposit in the northwest of Western Australia. Not only do we have the arrangement with Pilbara, but we also have a number of alliances and joint ventures capable of ultimately feeding material into Sileach processing hubs around the world. Those include the Sileach Resources joint venture at Sonora, Mexico, Kazali on the goldfields, Focus Minerals on the goldfields, Tungsten Mining NL at the Seabrook Rare Metals venture, Venus Metals Corporation at Pilgangoora, and Metals Tech in Quebec, Canada. Metals Tech, of course, is the float for which Lithium Australia shareholders have a priority entitlement. Now, what do we expect to achieve by applying the Sileach process? One of the problems that you've got with past processing technologies, and I refer primarily to spodumene because it's the only commercially processed lithium mineral at the moment for the production of lithium chemicals. The problem with that process is it's energy intensive and it's expensive, resulting in an operating cost to produce lithium carbonate of about $4,500 a tonne. If you can drop the energy cost down, if you can get substantial byproduct credits, and if you can minimise your mining costs, the potential for extracting lithium using the Sileach process is comparable with the brine producers, those producers being the cheapest producers on the planet. To date, many of the undertakings of the company have been vindicated in terms of laboratory results, but more importantly on a larger scale and continuous by pilot testing at ANSTO Minerals at Lucas Heights in Sydney. That has successfully produced lithium carbonate, and all of the intermediate products, being solutions and solids precipitated in that process to get to the production of lithium carbonate, have been dispatched to Murdoch University, where the evaluation is being undertaken on impurity deportment and value-added byproducts. So our main thrust is the economic production of lithium chemicals from a range of silicate minerals, bearing in mind we want to have a low energy footprint, minimal exposure to mining cost and high byproduct credit. But behind that, we are developing a very significant portfolio of lithium tenements on a global basis. Now, some of these are on the back of global alliances in Australia, Canada and Mexico, which we've mentioned. But Lithium Australia also has 100% interest in a number of other projects, being Greenbushes in Western Australia, Ravensthorpe in Western Australia, Lake Johnson in Western Australia, the Gascoyne in Western Australia, Bino in Northern Territory, and also mineralisation on Cape York Peninsula. The reason behind doing this is quite simple. We've taken positions in all of the major lithium provinces on a global basis to provide feed for centralised processing hubs, should it be required in the event that we can't get it from third parties. So these are quite critical. I think I should elaborate there and just mention that we're treating Mexico as standalone, and the processing technology there to be applied to the clays may well be different to the Sileach process as we see it today. That incidentally contains the extensions of the giant Sonora deposit that is operated by Bacanora Minerals. In conclusion, I'd just like to recap on a couple of things. We're developing technology that we believe will make the lithium industry much more sustainable. And just remember what I said about the comparison between froth flotation and the Sileach process. There's a great opportunity out there, and we intend to capitalise on that opportunity with a process that's got a low energy footprint, high byproduct credits, and develop key partnerships to establish centralised processing hubs around the world. The potential to capitalise on material that other people don't want is critically important to our business plan, in that there is an enormous amount of lithium currently going to tailings, various waste streams that's never harnessed, and we plan to harness the value of those streams and focus on the material that other people don't want. In addition to processing the materials that other people don't want, we believe there's a huge opportunity in recycling, because there's such an enormous gap between what's produced and pumped into the current market and what's recovered. And the recovery of those materials should be no different to, and in fact, quite a bit better than processing low-grade ores. The concentrations are quite high, and as a consequence, they have, I think, long-term, a bright commercial future. So we're well down the path to sorting out the technology. We're having a good look at the recycling. We are developing strategic partners, and we are there in all of the major lithium provinces around the world, and we look forward to a very fruitful 2017.